the medians and altitudes. Now, just like yesterday, all these lines are going to, when we put them inside the triangle, they're going to cross at the same point. So in turn, they're still going to be concurrent lines. That point that they cross at is still going to have a specific name. The names today are not going to be as obvious as the ones yesterday in terms of helping you do a problem. Okay? Like yesterday was circumcenter was the center of a circle, and incenter was also the center. The ones today, not going to be key. All right, first thing, definition of what these lines are. Okay? Median. No matter what, whatever we're dealing with, if you ever hear the word median, we're talking about drawing it essentially what people would imagine as down the middle. It doesn't really split a triangle in half, but what it does is it goes from a vertex to a midpoint. So anytime you draw a line from a vertex to a midpoint, create a median. Something like that. Okay? Now, like I said already, just like yesterday, if we were to go up there and go to each side, find the midpoint of each side, there, just say maybe there. And I were to connect medians to all of them. So like if I was to draw a median to this midpoint, I would have to draw it from this vertex. Okay, if I were to connect this one, I would have to draw from the point C. If I were to do this and it's 100% accurate, they will all pass at the exact same point. Okay, just like yesterday. So in essence, the stuff that we talked about yesterday is very similar to today. And the fact that you're going to have 3 lines crossing at the same point. Making them, like I said, concurrent lines. Like the definition is. All right? I'm going to go back to the actual. I need to come back to it, I will. Okay, now dealing with what I just said, if I were to draw in all the medians, okay, like I just showed you, they're all going to cross at the same point, just like the stuff here. And so like yesterday, that point that they cross at is going to have a specific name. The one today, so this one is called a centroid, right? Out of all of the names, like we're going to have a total of 4 names for these points. The 2 yesterday, the circumcenter, the incenter, and then this one here, centroid, and then there's going to be one other one. Out of those 4, the 3 that we've already covered, including this one, are going to be the more important ones, because those are going to lead you to ways to solve a problem. Like yesterday, if you saw an incenter, you could draw an inscribed circle and then find the radii. If you had a circumcenter, you could draw a circumscribed circle and find all the radii being the same. Okay? The centroid, I don't know the typical background of it, like I don't know the history of the name, I never looked it up. But I would assume the word centroid is probably formed from the fact that when you draw all the medians, that point where they cross is the actual balancing point for that, the weight of like that object. So like if you cut a triangle out in cardboard or something, or like a rigid surface, and you actually drew in all the medians, you could balance it like on the tip of a pencil or something like that. That would be the actual center of mass. And that's where I would assume the name is coming from. Okay, so this might be referred to as the balancing point, the same thing as the centroid. Okay, but just like yesterday, you need to make sure you're keeping track of these names, okay, the names of the points, as well as which lines are forming them. So you should get medians and centroid kind of coexisting together. You should get perpendicular bisectors and circumcenters together, angle bisectors, incenters together. So that anywhere like right now or even beyond this, when we have a triangle and those words come up, your brain should automatically click the two words. Like if I say in the directions there's angle bisectors, you should say, oh, there's probably an inset there. Okay? Now, the properties for this. And again, remember that everything we're doing is relating to how we can find lengths of these segments inside the triangle. Okay, and for today there's 6 of them. If you just kind of look at them in terms of this right here, I mean, you should realize these really aren't going to be equal to each other. There's going to be one, like yesterday we had things equal, today not so. All right? But what happens is whenever all these three cross at this point, the centroid right here, what this point does is it breaks them up into thirds. Okay? Instead of a 1/2, you're dealing with maybe a 1/3. All right? And the way it's going to go is, and I'll have it written out, but the way it's going to go is all the smaller segments are 1/3 of the entire length of the median. Okay, so like if I know this median is like 15, and I said find this, you just divide it by 3, which is 5. Okay, so this is the only one that's different from what we did yesterday. Yesterday everything was equal, here not so much. Okay, now, this would be the properties of it. Now the actual theorem or that they have written down in the book in the FN form deals with things being 2/3. Usually it's easier for people to deal with a fraction that's like a 1/3 as opposed to a 2/3. So if you would rather write this out as something like maybe FP equals 1/3 BF, and then EP is 1/3 AD, and EP 1/3 EC. Like if you want to look at this fraction as opposed to 2/3, which a lot of people like to, because there's a 1 on top, so that 1 on top means you just divide by whatever the denominator is to get your answer. If you want to write it that way, that's fine, because both of those will be able to get you the exact same answer. Okay, so either remember it as the small portion is 1/3 of the entire median that it's on, or you remember the larger portion of it inside is 2/3 of the entire. Yes.
Can you want to say that again?
That would be the property for that. Now, the other thing you could write, like just realizing that relation-wise how these two work. Like if I said, I'm going to compare BP and PF, like these two together. If you look at it, like this one right here, by definition up here, this is 2/3 of the entire thing. And when I wrote over here, FP is 1/3 of the entire thing. That means that BP is twice as big as this one. So that's another method you might be able to use. So like if I told you, just say from E to P was like 10, I said find X. You don't necessarily need to know the entire length. You just need to remember this part is twice as big as this one. If that's 10, that's 20. Okay? The whole 1/3 and 2/3 thing, that's going to come more into play when you have the entire length of the median. So like when you have, in this case with the letters they have, if you have AD, BF, or CE. Okay, so 2/3, 1/3. All right, and I'm just labeling them that way just so you can kind of visually see where they're at. And it's always of, like the 1/3 and 2/3, it's always of whatever median they're on. Like this one's EC, AD, and this one here is BF. Okay? And like for the work today, guys, this is the only thing that's gonna be involving numbers. Alright, with the exception of maybe they would throw in stuff from the past couple of days, which you still need to recognize, if I throw in like a perpendicular bisector, you should be able to realize, where the radii are in relation to a circumscribed circle like yesterday. But for the new stuff today, this will be the only thing involving actual numbers. Okay, the other thing, the altitude is all going to be identification. So I'm going to do probably one example of these. Probably really neat. Can I go past it? Yeah, I need to sit here for a second. Oh, okay. HQ, JA. And then I need a point here because I'm going to draw a midpoint. Which one? What? S? What is that, S? F? Alright, so. Oh well. I'm just making this a really big point. They intersect. And what? And. Alright, so just for a typical type of problem you'll see here. You got your diagram there. They're going to assume, or I'm going to assume at least when I give you the problems on test, that you should be able to look at it and go, these are all midpoints. That line connects to the vertex. That makes these all medians. You go, okay, so I've got medians there. That means that point N is the centroid, which should lead you back into the whole 1/3 and 2/3. All right, like this should all be going on in your brain as you're doing these problems. Okay, you identify what segment's there, you identify what that point's called, then you go into the problem. All right, so let's say for the first one we'll do like, we'll say like QP is, I don't know, 21. Okay, all right, QP is 21. What is the length of QN? Means what? 14. How? Okay, so this, like you said, would be 1/3 of the entire thing. So 1/3 of 21 is 7. And then you just subtract, right? So that would be 14. Okay? Usually with these, like you could have done like, you could have done 21 times 2/3, got the same answer. But for most people, it's easier to go ahead and take that number, divide by 3, get the shorter one, and then just subtract. Everyone freaks out when there's another fraction.
How do you know whether QN is the 7 or 14 or NP?
Whatever's the shorter one. It should be obvious what's the shorter one. Like if I looked at NF, I understand NF is a lot shorter than HN.
Oh,
So I know that's a 1/3. Okay. They should. The problems I will always give you, I can't comment on how the book does, because sometimes the book is odd. But all the ones I will give you, it will be obvious which one's shorter and which one's long. Like there won't be a question on, oh, they look like they're about the same size. Okay. All right, so that's one. All right, so that'd be an easy one. What if I did like, and how much you want Fn to be? 32? Alright, so if Fn is 32, so this would be a given thing, and I say find Hn and HF. So I'm saying on this one, that's 32, I want you to find this one and the entire thing. What would that be? Quick, just be quick. HN is what? 64, right? So these two, this is twice as big as that one, so 64. That would make the entire thing? Yeah. The problems aren't that hard. Just like yesterday, they're not that hard. It's just you have to identify where, like in this case, the 1/3, 2/3, 1/2 until. It's not going to be much more involved than that. Okay? The chapter is really about being able to identify the correct thing and then applying a fairly basic property. Okay? All right. So let's move on to the last bit. Suppose it's not going to be that hard. So the altitude. Now with these guys, like for today, there's really not going to be any straightforward examples. As like to where you're doing numbers. With these, like there aren't going to be crossing lines where things are equal, that kind of thing. Altitudes, by definition, guys, an altitude is drawn from a vertex to a side, and when it's drawn in such a manner that it creates a right angle. They're perpendicular. Okay? Since it does create a right angle, I mean, there could be problems that involve like the Pythagorean theorem or something. But I highly doubt that right now you will see that in the work. It just could be. Most of the stuff with the altitude right now is going to be identifying it. And the reason you need to identify it is because an altitude is always the height of the triangle. That's the reason you need to find it. So when we get to area stuff, or if you ever did area stuff, which we already did, you do 1/2 base times height. The height that you use is technically called the altitude. All right? That's the reason they might use that term. Right? Altitude means height, how high it is. Yes. And isosceles triangle. Okay. So understand, some of these are going to overlap. Like if it's an isosceles triangle and you're drawing an altitude, it is also a perpendicular bisector. So there is a case where you will have one altitude that is the same as a perpendicular bisector. Okay? Now, on these right here, both of these, I'm going to put some foot letters over here. Give me some letters here. J again? C?
Yep.
What? O, your L, L. All right, so what I was going to get at here, guys, on both the triangles up there, the one on the left and the one on the right, both of them have the 3 altitudes drawn in there. Okay? Usually with right triangles, people, if I put the altitudes of a right triangle there, most people only identify one of them. Like in terms of the triangle that's there. And that would be JM. That's the altitude. The thing is, people forget, altitude just means it makes a right angle with the side when it connects to a vertex. That's an altitude. JM, ML is also an altitude. All right? So in a right triangle, guys, the 2 sides are also altitude. That's why if you ever do the area in terms of like a 1/2 base times height thing for area for a right triangle, you can always use these 2 numbers as the base and height. All right? So many people want to, if I give you an area problem, like even when we get to that chapter way down the road, and we're doing an area problem and it's a right triangle, so many people want to draw on this line. You don't have to. Not a necessity. Okay? Just understand that this line, this one, and this one are all altitude. All right? The ones over here would be more obvious because they're going to cross inside of it. So you would have JL. Like over here, you would have JL. We would get TD and OC. Right? Now, again, the whole purpose of this, for the altitude stuff, is simply so that you can identify these and identify them as the height of the triangle. Okay, because that's how they're going to get used eventually. All right? But outside of that, there isn't much else to it. Now, the only other thing you have to know for the altitude is the name of that point right there where they cross. Okay? Which, in this case, they would all cross right here. Okay? So this right here would be the point where they all cross. That's a point of concurrency. There's this one. Just like the other one. That has a specific name. It's called the orthocenter. So this would be the fourth one. So I'm telling you now, the ones I'm mostly going to focus on are the ones that we've done prior. Circumcenter, incenter, centroid are the more important ones because there's specific properties that come straight from them. For what we're doing right now. We're probably not going to apply the orthocenter thing that much. But know it's there because it's going to get referenced in problems for homework tonight, review stuff, anything. But I'm going to mostly focus on the first three. Okay? Alright, so altitude, guys, you know how to draw it, you know how to identify it, know that name right there, where they all cross. So M right here is an orthocenter, that's an orthocenter right there. Okay, the point can be on the triangle, guys, that is allowed. Okay, that happens with the perpendicular bisectors also. Okay? Alright. That's it. Well, I already said all this. There you go. All right, another fairly short day. Don't forget, guys, right, the test will be next Tuesday. Means that can maybe be done with this chapter by Friday. And then probably the day after the test, we're probably going to do some, whatever that first progress monitoring test is. What you got to do on the computer now. As long as I can keep computers for that Wednesday. I want to do it before we start the next chapter. I want to start a chapter and have to stop in the middle. Oh, you mean like, well, 5 is 10 to 38. I didn't